So, hi, I'm Rosanna Liginhawa from Mighty to Uchi. So, welcome to my channel. So, first, from the chapter 5, I briefly discussed to you the summary of this chapter, which is the Ethernet. So, the OSI physical layer provides the means to transfer the bits that make up the data link layered frame across the network media. Then, So from this chapter 5, so the Ethernet is the most widely used LAN technology today. So it is a family of networking technologies that are defined in the IEEE 802.2 and the 802.8 standards. So the Ethernet standards define both the layer 2 protocols and the layer 1 technology. So for the layer 2 protocols, as with the all 802 IEEE standards, the Ethernet relies on the two separate sublayers of the data link layer to operate. So the logical link control LLC and the MAC sublayers. So at the data link layer, the frame structure is nearly identical for all bandwidth Ethernet. So the Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. So there are two styles of Ethernet framing. So the IEEE 802.3 Ethernet standard and the DIX Ethernet standard, which is now the referred to Ethernet 2. So the most significant difference between the two standards is the addition of a SART frame delimiter, or the SFD, and the change of the type field to a length. Then the field in the 802.3 Ethernet 2 is the Ethernet frame format used in TCP/IP network as an implementation of the IEEE 802.2 3 standards. So the Ethernet frame provides MAC addressing and error checking. So from the layer 2 addressing provided by the Ethernet supports unicast, multicast, and the broadcast communication. The Ethernet uses the address resolution protocol to determine the MAC addresses of destination and map them against known as IPv4 addresses. So each node on an IPv4 network has both a MAC address and an IPv4 address. Then the IP addresses are used to identify the original source and final destination of the packet. So the next one is the Ethernet MAC addresses are used to send the packet from the Ethernet NIC to another Ethernet NIC on the same IP network. So the ARP is used to map a known IPv4 address to a MAC address, so the packet can be encapsulated in an Ethernet frame with the correct layer 2 address. Then the next one is the ARP. So the ARP relies on certain types of Ethernet broadcast messages and the Ethernet unicast messages called the ARP request and the ARP replies. So the ARP protocol resolves IPv4 addresses to MAC addresses and maintains a table of mappings. So on the most Ethernet networks and devices are typically connected on a point-to-point basis to a layer 2. So a full duplex switch, a layer 2 LAN switch, performs switching and filtering based only on the OSI data link layer. So the layer 2 MAC address, a layer 2 switch builds a MAC address to table that is used to make forwarding decisions. So the layer 2 switches depend on the routers to pass data between independent IP subnetworks. So after that, I have here a few questions for you to understand what is from chapter 5. Then this is the first question that I've that I've been given to you. So this is the first one. So what happens to run frames received by a Cisco Ethernet switch? So the answer is the frame is dropped. So I explained to you why the frame is dropped is the answer. So in an attempt of converse bandwidth and not a forward useless frames, Ethernet devices drop from frames that are considered to be run less than 64 bytes or the jumbo greater than 1500 bytes frame. Then uh, so what statement what describes an Ethernet? So for me, Ethernet, it defines the most common LAN type in the world. So Ethernet is the most common LAN protocol in the world. So it operates the layer 1 and 2, but it is not required for internet connections, or the OSI model is used to describe how networks operate. One connects multiple sites located in different countries. So my next question is, give at least two statements describe the features or functions of the logical link control sublayer in the Ethernet standard. So the two statements that describe the features of or functions of the logical link control sublayer in the Ethernet standard is the logical link controls are implemented in software. Then the second one is the data link layer uses LLC to communicate with the upper layers of protocol suite. So I'll explain to you the two of why the two is the two statement that describe the function of the logical link control sublayer in Ethernet standard. So the logical link control is implemented in software and enables the link layer to communicate with the upper layers of the protocol suite. So the logical link control is specified in the IEEE 802.2 standard. That IEEE 802.3 is a suite of standards that define the different Ethernet types. So the MAC, or the Media Access Control sublayer, is responsible for the replacement and retrieval of the frames of the media, and the MAC sublayer is also responsible for adding a header and trailer to the network layer protocol data unit, or the PDU. So my third question is, what statement describe a characteristic of a MAC address? So the first one, so the MAC address, so it should be a globally unique. So why? So I'll explain. So for example, any vendor selling Ethernet device must register with the IEA to ensure the vendor is assigned a unique 24-bit code, so which becomes the first 24 bits of the MAC addresses. Then the last 24 bits of the MAC addresses are generated per hardware device. This helps to ensure globally unique addresses for each Ethernet device. So my next question is, give at least one statement about MAC addresses. So for me, the first one statement from the MAC is about MAC address is the first 3 bytes are used for the vendor assigned in OUI. So that's one an example about MAC addresses. Then so I will explain. So a MAC address is composed of 6 bytes. So the first 3 bytes are used for vendor identification, and the last 3 bytes must be assigned a unique value within the same OUI. MAC addresses are implemented in hardware. An NIC needs a MAC address to communicate over the LAN. So I think that's all for this chapter summary activity. So Thank you for watching.